So now our next concept is homogeneous system of linear equations. So here also first we'll see what is this homogeneous system of linear equation, and then we'll see how to find consistency of homogeneous system of linear equation. So this was our earlier system of linear equations. We had three equations and three variable. Now if this constant term is 0, if d1, d2, d3 these are 0, then in that case we say that this system of linear equation is homogeneous system of linear equation. You have only, so the equation will be of this form: a1x plus b1y plus c1z equals to 0. Similarly, a2x plus b2y plus c2z equals to 0, and so on. So this system of linear equation is called homogeneous system of linear equation. Now here if you want to calculate if you want to write augmented matrix, so the augmented matrix will be a1 b1 c1 0, a2 b2 c2 0, a3 b3 c3 0. This is your coefficient matrix: a1 b1 c1, a2 b2 c2, a3 b3 c3, and the first three column plus this constant matrix, which is all the 0 elements. So this matrix is augmented matrix. Now you can easily see that for homogeneous system of linear equation, the rank of coefficient matrix A, these first three columns are the coefficient matrix. So rank of coefficient matrix A is always equal to rank of augmented matrix A by B, because this C4 is always 0. So the rank will be decided by only these first three columns. So in case of homogeneous system of linear equation, this relation is always true. Rank of A is always equal to rank of A by B, and this means the system of linear equation is always consistent. So now we have to find what should be the condition for consistency with unique solution and with infinite number of solution. And see, this result was obvious. Always consistent is obvious. The reason is that x equals to 0, y equals to 0, and z equals to 0 will always satisfy all the three equations. Let me take a proper example here. Suppose if the equation was, say, 2x plus y minus z equals to 0, x minus y plus z equals to 0, and say 2x minus y plus 4z equals to 0. So you can easily see that x equals to 0, y equals to 0, z equals to 0 is always the solution of this system of linear equation. Okay, if I place x equals to 0, y equals to 0, and z equals to 0, then it will satisfy all the three equations, and therefore there is no possibility of no solution. This is always the solution. So now either you will have unique solution, in that case you will have only one solution, or you will have infinitely many solutions. Also this solution is called trivial solution. x0, y0, z0 is called trivial solution. So for homogeneous system of linear equation, this trivial solution will be always there. Now we have to find what should be the condition for unique solution. Unique solution will mean only trivial solution. And what should be the condition for infinite number of solution? So see, the condition for unique solution was, for unique solution, in our earlier discussion we have seen that condition for unique solution was rank of A is equal to rank of A by B, okay, and this was equal to number of variables. If rank of A is equal to rank of A by B and is equal to number of variables, then in that case you will have unique solution. Now here for this particular example, what should be the condition? For homogeneous system of linear equation, this condition is always satisfied. Rank of A is always equal to rank of A by B. So if I have three equations in three variables, then for unique solution the condition will be rank of matrix A, or you can say that augmented matrix A by B, this has to be 3, and this will mean that determinant of this coefficient matrix A, this will be non-zero. This we have already seen in our earlier discussion, that if determinant is non-zero for a 3 cross 3 matrix, then the rank of that matrix will be 3. So for unique solution, the condition will be determinant not equal to 0. This is very important condition. If you have a system of homogeneous linear equation and you calculate the determinant, if determinant is non-zero, then in that case you will have unique solution. And what will be the solution? We already know that this is always the solution. So determinant non-zero, we can write this thing in this manner: determinant of A not equal to 0. This will mean that homogeneous system of linear equation will have unique solution, and the solution will be only trivial solution. Means the solution will be x equals to 0, y equals to 0, z equals to 0. Only these three, this will satisfy all the three equations simultaneously. And for infinitely many solution, for infinitely many solution, the condition was rank of A is equal to rank of A by B and is less than number of variables. This was the condition for infinitely many solution for any general system of linear equation. Now here for homogeneous system of linear equation, this condition is always true. So what should be the condition here? Here the condition will be rank of coefficient matrix A. Now for this particular example we have 3 variables, so this means rank of matrix A, this should be less than 3, which implies the determinant of coefficient matrix will be 0. So again you have to remember only these 2 conditions. If determinant is non-zero, then you will have unique solution. If determinant is 0, then in that case you will have infinitely many solution. So determinant not equal to 0, unique solution, only the trivial solution. Determinant equal to 0, this means infinitely many solution. Infinitely many solution, and this will mean trivial plus non-trivial solution. Trivial plus non-trivial solution. Trivial solution means all the 3 variables x, y, z are 0. Non-trivial means at least one of them is non-zero. So if determinant is not equal to 0, then you will have unique solution. If determinant is 0, then you will have infinitely many solution, and the solution will include trivial plus non-trivial solution. Now we will discuss 2 examples, and with the help of those examples we'll see this concept in detail. Okay, so our first question on homogeneous system of linear equation is, we have to comment on the consistency of following system of linear equation. Now these 3 equations are given. Since the right hand side is 0, therefore this system of linear equation is homogeneous system of linear equation. Now we know that homogeneous system of linear equation is always consistent. So here we have to find whether this is consistent with unique solution or it is consistent with infinite number of solution. So for that we have to calculate the determinant of this coefficient matrix. If the determinant is non-zero, then it will have unique solution and it will have only trivial solution. Trivial solution means all the 3 variables are 0. And if the determinant is 0, then in that case it will have trivial plus non-trivial solution and it will have infinitely many solution. So the determinant of this coefficient matrix will be 2, 1, 1. This will be our first row. Then our second row will be coefficient of x is 0. So 0, 1, minus 1. And then our third row will be x plus y plus 0, z. So this will be 1, 1, 0. Now we have to find this value. So if I expand this determinant along the first column, because we have 1, 0 here, so this will require less calculation. So I'm expanding this along C1, so I will get 2 into 1 into 0, 0, minus, minus 1. So this will be 0 plus 1, minus, now 1 here, so I will get plus 1 here, minus 1, minus 1. So this will be minus 2, 2 into 1, 2, minus 2, 0. Now the moment we have seen that determinant of coefficient matrix is 0, this implies that the system of linear equation will have infinitely many solution. Infinite number of value of x and y is possible, which will satisfy all the 3 equations simultaneously. And here we will have trivial plus non-trivial solution. Trivial solution is always there. If we have infinitely many solution, then in that case we'll have non-trivial solution also. Now let me explain the meaning of this non-trivial solution. First, how to write the solution if we have infinitely many solution. So for that you can see that your second equation is, our aim is that we have to write the other 2 variable in terms of first variable. So from equation 3 you can see that y is equal to minus x. From the second equation you can see that y is equal to z. And y is nothing but minus x, so this means we can write that z is equal to minus x. From here I can write that z is equal to minus x. So y is minus x, y and z are same, so this means z is also minus x. And you can see that if I place these 2 values here, it will satisfy the first equation also. So now we have expressed y and z in terms of x. So our solution will be, in place of x, you can write the solution in this manner. Solution will be, you can write x as some number t, and then in that case y will be negative of x, so this will be minus t, and your z will be, z is also minus x, so this will be minus t, where t is some real number. So in this way we can write the solution, whatever be the value of t minus t minus t, this will always satisfy all the 3 equations simultaneously. So here if I substitute t equals to 0, then the solution that I will get is 0, 0, 0. So this solution is the trivial solution. And if I substitute say t equals to 1, so in that case the solution that I will get is 1 minus 1 minus 1. Similarly, if you substitute t equals to 2, then you will get 2 minus 2 minus 2. So all these are non-trivial solution. And when t is 0, then this solution is called trivial solution. So that is the meaning of this trivial and non-trivial solution. If all the variables are 0, then the solution is called trivial solution. If any one of the variable is non-zero, then the Okay, so our first question on homogeneous system of linear equation is, we have to comment on the consistency of following system of linear equation. Now these three equations are given. Since the right hand side is 0, therefore this system of linear equation is homogeneous system of linear equation. Now we know that homogeneous system of linear equation is always consistent. So here we have to find whether this is consistent with unique solution or it is consistent with infinite number of solutions, because the right hand side is 0. The constant terms are 0. Now in the question it is given that this system of linear equation has non-trivial solution and we have to find the value of k. 4 options are given. So we have just learned that condition for non-trivial solution is, for non-trivial solution or infinitely many solution, these two are the same thing, infinitely many solution. When you have infinitely many solution, then you will have trivial plus non-trivial solution. So for non-trivial solution, the condition is that the determinant of coefficient matrix, this has to be 0. Only then you will have non-trivial solution. If determinant is non-zero, then in that case you will have only the trivial solution. So here if I calculate the determinant of coefficient matrix, our first row will be 3k minus 8, then you will have 3 here, 3 here. Then our second row will be 3k minus 8, then again 3, and the third row will be 3k minus 8, and this has to be 0 if the given system of linear equation has non-trivial solution. Now we have to solve this determinant, and from here we have to see what are the possible value of k. So we can solve the determinant here. You can see that if I add all the elements if I add these elements, say if I add c1 plus c2 plus c3, then you can see that you will get 3k minus. So after this, if you do the calculation, if you add all the three columns, c1 goes to c1 plus c2 plus c3. We know that in the case of determinant, this will not change the value of determinant. So if I add all the three columns, then I will get 3k minus, now minus 8 plus 3 plus 3, so this will give you minus 8 plus 6, so this will be 3k minus 2. Then similarly here also I will get 3 plus 3k minus 8, so this will become 3k minus 2, and here also we will get 3k minus 2. Then our second column will be 3k minus 8, 3, and 3k minus 8, this will be 0. Now you can see that in first column we have all the three elements same. So now we have to create two zeros in order to expand this determinant. So I can perform this operation, R2 goes to R2 minus R1 and R3 goes to R3 minus R1. If I have two zeros, then it is very easy to expand the determinant. So if I perform these two operations, R2 minus R1, R3 minus R1, so our determinant will be 3k minus 2, 3. Then I will get 3k minus 2, so I will get 0 here, 3k minus 8 minus 3, so this will be 3k minus 11, 3 minus 3 is 0, and in place of R3 I am going to write R3 minus R1, so you will get 0, 0, 3k minus 11, this equals to 0. Now if you expand this matrix along the first column, then you can see that you have two zeros in first column, so you can write this thing as 3k minus 2, this multiplied by, now you have to erase the first row, first column, so you will get 3k minus 11 square, this equals to 0. So from here the value of k that you will get, from here you will get k equals to 2 by 3, and from here you will get k equals to 11 by 3, and since you have a square here, another 11 by 3. So these are the three possible value of k for which the given system of linear equation will have non-trivial solution. So you can see that our correct answer will be 2 by 3, 11 by 3, 11 by 3. This is our option D. So this will be the correct answer. So this was a very good problem. You should know the meaning of all these terms, trivial solution, non-trivial solution. When you will have infinitely many solution, then you can easily solve these type of problems. So after this, our next topic will be eigenvalue and eigenvectors.